guys, here we go again, talking a little bit about some of the lovely ILT I've set you, because, you know, yay. So, here we have questions on ionic bonding. We have an ion of element X can be represented, okay, as this, okay, so it tells you two things here, okay. We've got the mass number here, okay, this is the mass number, and it's also told you it's an ion and it has a -2 charge, okay. These are important facts. Now, it first of all asks you the number of protons. Now, it doesn't give you the atomic number, so therefore you have to work this out. Now, if it has 54 electrons in total, okay, and its charge is -2, we have to remember it's gained 2 electrons, so it has 2 more than it does when it's an element. Therefore, the number of protons will just be 2 less than 54, which is 52. Okay. Now, to find out therefore the number of neutrons, we just do 125 minus 52, which equals 73. Lovely. Now, it says calcium oxide is an ionic solid. Complete figure 6 to show the electronic configuration of the charges of the calcium ion and the oxide ion. Okay, include the charges on both ions. Okay, so calcium, of course, is in group 2. It's in group 2. So it has 2 in the outer shell. That means it's going to lose 2. Okay, so that one there and that one there are both going to get lost, right? So actually, all we're going to have, if I can draw these dots without smudge, we're going to have basically 8 in this shell. Okay, and the 2 on the outer shell will have been lost. Okay, there's 1 and 2. Now, in terms of the O, it had, I'll just draw little X's, it had 6 up there. I like to draw them in pairs, makes them easy to count. They didn't draw them in pairs, that's fine, okay. Now, the 2 from here, of course, very simply, we'll draw a dot, just went there, giving that a charge of -2, and that a charge of +2 or 2+. Okay, nice. That's another 3 marks. Job done. 1 mark for the calcium, 1 mark for the oxide, and 1 mark for the charges. Now, our next question, question 7. I've jumped around a bit. I cut some questions out just to make it all good. Okay, we have to talk about magnesium carbonate, which has the formula MgCO3. Now, this contains Mg2+ and CO3 2- ions. Now, the atomic number of magnesium is 12. Okay, so it's 2.8.2. What is the electronic configuration of the Mg2+ ion? Now, as you know, hang on, I thought that was an eraser, but it's not. It does that. Anyway, as you know, basically, those 2 are going to go away. That's what's happening, right? We're losing those 2 electrons, okay? So, what's left, essentially, is just 2,8. So it's B. Now, explain why solid magnesium carbonate cannot conduct electricity, but solid magnesium can. Now, magnesium carbonate, this is ionic, whereas magnesium is metallic. So essentially, it's saying, why can't a solid ionic substance conduct electricity, but why can a solid metal conduct electricity? Okay, basically you should know that the ions in magnesium carbonate cannot move. Okay, they are held tightly. Okay, however, Mg, magnesium, contains delocalized electrons which can move and carry a, what do they carry? That's right, a charge. Wow. Now, if you want to be really super duper fancy, you can just say throughout the structure, i.e. like that, A to B, not randomly in a set way. Now, delocalized, I'll say it's probably a very much higher tier word. You can say it in foundation, okay? You could also say free for a foundation, okay? But I would say delocalized is needed for higher. Make sure you say that if you're a higher tier candidate. And if you want to say it as a foundation candidate, you do. They will not deduct you marks for using terminology. Right, okay, across in the correct box. Magnesium has the atomic number of 12. Which line shows the correct number of protons, neutrons, and electrons in a magnesium ion? Ooh, it's thrown that at you. Now, they are essentially, okay, expecting you to go with basically 12 and 12. They're going to think, ooh, they haven't noticed the ion. They're going to think it's 12 and 12. But you guys know better. So Mg, of course, 2 plus will be 2.8, meaning it's only got 10 electrons. It actually has 12 protons. Okay, so therefore the answer has to be D. It doesn't give you information about neutrons. Okay, you don't need that to work it out. Nice. Now, next one. We have a bit of a jump here, all the way up to question 16. So it says, explain why sodium chloride solution rather than solid must be used. Well, ions can move in solution. Basically, ions can move in solution. That's why. Now, the formula of the ions present in sodium chloride are, there they are. Okay, they're a bit small, but it's Na plus, Cl minus, H plus, and OH minus. Okay, circle the ions that would be attracted to the anode. Okay, so which ions are going to be attracted to the anode? Now, the anions will be attracted to the anode. Okay, and what is the charge of an anion? Well, an anion is negative. So that one and that one will both be attracted to the anode. It says molten lead bromide can be electrolyzed for molten lead and bromine gas. Explain how a student could modify the apparatus shown in figure 8 to carry out this experiment. Well, first of all, okay, you're going to need to not do it in a glass beaker. Okay, you're going to need to use a crucible, which is more suitable to be heated strongly. Okay, as you need to melt the lead bromide. It's molten. You need to melt the lead bromide. Melt, not dissolve in water, the lead bromide. Lovely dovely. Right, next. I may have just made that statement up. Anyway, number 17 says, sodium chloride is an ionic compound containing sodium ions and chloride ions. Okay, it then says, figure 15 shows the electron configuration of sodium and chlorine. Explain how sodium and chlorine atoms form the ions in sodium chloride and how the ions are arranged in solid sodium chloride. So let's do this one at a time. So sodium 281, okay, it will lose 1, write the word, 1 electron. Okay, you have to write the word. I know an electron, 1 electron, kind of the same, write 1, okay. So it'll lose 1 electron to form Na plus ion. Brilliant. Now, chlorine gains. How many does it gain? 1 electron to form Cl minus ion. Okay. Now, Na plus ions attract Cl minus ions because opposite charges attract. Opposite charges attract. Okay. Now, this will form an ionic lattice. Okay. Now, don't want to describe an ionic lattice? Why don't you draw one? Essentially, each sodium ion will be surrounded by ultimately 6, but you can't draw this 3D here because there'll be one in front of it and one behind it and so on, and basically there'll be an alternating pattern of positive and negative ions there, like so, and that one will have Cl next to it, Cl, and that should be a plus, shouldn't it? Cl plus, Na plus, that'll have Cl, which will have another Cl minus. You could go on forever, but I won't. Okay, essentially it's a lattice. This is our lattice here. You can draw it. You can draw it to show you understand what it is. They allow that. That is in lieu of a written description. That is allowed. Okay. Now, last couple of pages. This one is just an extension page of the page we've already done. It's more space to write stuff on. Maybe draw your lattice diagram. I don't know. Maybe you didn't use it. Maybe you did. It's a lot of room. The next one asks you, the next and final one, asks you to write about two substances. It says one of the substances is ionic and one is simple molecular. It's very nice of them to tell you that. They might have expected you to work that out. Explain in terms of bonding and the forces between the particles, the relative melting points and abilities to conduct the electric current of substances A and B. Now, you can tell, by the way, that this is covalent. A is simple covalent. Okay, because it has a low melting point and does not conduct. Okay, you can work that out. Now B obviously therefore is ionic because it has a higher melting point and conducts when molten. Now you need to justify, you need to explain why these are what they say they are. Okay, now I've kind of just done that, but let's just work through it methodically. Now, why does A has a low melting point, as we've said? Okay, but why? It's because they have weak intermolecular forces, which require little energy to break them. Okay, that's it. That's why they have a low melting point. Now, why don't they conduct? They don't conduct as they do not contain charged particles to carry a charge. Okay, that's A. Now that's roughly 50% of it. Okay, that's roughly 50%. So A is, therefore, let's just clarify again. A is simple covalent. Okay, that's what it is. Now, let's very quickly, before we go, because while we seem to have finished, we actually haven't done half of it. B, okay, has a high melting point. So B is ionic. Now it has a high melting point because it has strong. Now what's the name of the forces in ionic? You need to know those. Strong starts with an E. Good. Electrostatic forces of attraction. Okay, it has strong electrostatic forces of attraction. A lot of energy is required to break these, essentially. There we go. So, high melting point. Now, equally, conductivity. Know when solid, as the ions aren't free to move. Yes, when molten, as the ions are free to move, essentially. Nice, nice, nice. Okay, now I hope this has helped. Hope this has helped with that homework, with that ILT. Good luck finishing it, and I'll be seeing it when I look at it. Have a good evening, guys.